All right, here we go. We're going to take a look at trig derivatives. If this is hilarious to you, then you're ready to do some trig derivatives. Obviously, you got the sine of gerene over the cosine of gerene. What is that? Tangerine hilarity. All right, let's do this. Let's get some derivatives going here. I want to take a look at the graphs of this. We could do the whole limit of the definition of a derivative if we want, but let's just take a look at the graph. I went ahead and graphed the sine of x for you here. Can you graph its derivative? Well, when I'm graphing these derivatives, remember I'm looking for these right here. This is when the slope of the tangent line is 0. So I know that the derivative is going to be 0 here. So anytime you've got a max or a min, it's going to be in the derivative, it's going to be 0. That's the slope is 0. So that is a huge idea that's going to keep coming up here with us. And then what is the slope of the tangent line here? You can see what? It's always positive. Anywhere you draw a line in here, you're going to have a positive slope. So it's kind of like flat, and then it gets steeper, and then the slope of the tangent line gets flat again. Well, what does that look like? Well, you've got a low slope. It kind of comes up to here, and then it comes back down. What's the slope of the tangent line on this side? Well, it's always negative. So between these 2 points, it's negative. Holy cow. Look at this bad boy. Does anybody know what this is right here if I kept it going? That's right. Maybe you can recognize this graph is actually the cosine graph. So check it out. So f prime, the derivative of sine is what? Is cosine. And we can do more formal algebraic proof, but that is true right there. The derivative of sine is cosine. Go ahead and pause it, and you try to find the derivative of cosine by graphing it. Good luck. All right, did your graph look like this? Hopefully you came up with this graph. And what is the derivative then? Well, this looks like a sine curve, but careful, what's it starting in the negative direction, so it's actually the negative sine of x. So if you came up with that, you are a boss. That is the derivative of cosine. Excellent. So let's go ahead and do all 6 trig functions up here. So the derivative of sine, we just showed it graphically, is the cosine of x. The derivative of cosine is negative sine. Now let's do the weird ones. I'm not going to prove all these. If you want to prove them, you can. I'm just going to give them to you so you have them. Tangent actually makes secant squared x. And the way I remember this is, where do you like to get tan? By the c, secant squared. Ooh, that's rough. That is rough. But as long as you remember it, how about cosecant? Cosecant is actually going to give you, obviously, negative cosecant, cotangent. So it's weird. You're going to times them together. Secant's going to give you actually secant tangent. And cotangent derivative is going to be the negative cosecant. So this is kind of weird, but a couple things to help you remember this. I like to think about this. The cos are all negative, so all your cosines. So if you look at cosine, it's a negative sign. If you look at cosecant, it's negative. If you look at cotangent, it's negative. So all the things that start with co are negative, and I like to think they're kind of friends. Cotangent is going to make a cosecant. Cosecant is going to make cosecant cotangent. So we kind of got to memorize some things here, but the first 2, I guess you could graph every time, but just memorize them. You get tan by the c, and then what's the opposite? If tangent makes secant squared, well, cotangent is going to make cosecant squared. So if you can know your the reciprocal functions, you're good to go, and then secant makes secant tan. So I think hopefully by doing this, you're going to kind of memorize them. You're going to have to memorize them for the mastery check and test, and obviously for the AP exam. But if you want to use this chart in the beginning, just use it, try to memorize it, use it. The more you use it, hopefully it just kind of sinks in. So let's go ahead and use it. We just said we're going to use it. Let's try it. If I want to take the derivative, this is great. What is the derivative of the sine x tangent x? Well, derivative of sine is cosine. The derivative of tangent is secant squared. And I am done. Good to go. This is awesome. Love it. Let's pick it up a little bit because it can get kind of crazy here. That one was nice. If it's not written, if this is cosine of 3x, this really means the cosine of 3x. So sometimes we don't put parentheses in there. It's just this first little chunk after it is the angle. So if I want to find the derivative, well, what is the derivative of cosine? It is negative sine, no problem, of 3x. But guess what? We've got some chain rule going on. This is like saying the cosine of u. What do we do when we do the cosine of u? We have to take the derivative and get u prime. So this is the inside of it. So for chain rule, what's the derivative of 3x? It is 3. So technically, this would be negative 3 sine of 3x. That is the derivative. So we're going to have some mad chain rule going on here. I love it. I love it. Let's keep it. All right, here we go. Let's find some more derivatives here.
The next one says we got 3 cotangent x. So I put the little cheat sheet down here, but we're going to use these so much they're going to get memorized here. But always remember this co is going to be a negative. It's a co, so it's going to be a negative derivative. So if I want to find the derivative, I've just got this coefficient of 3 in front. It just comes right on down, just like it would in the power rule. And what is the derivative of cotangent? Derivative of cotangent is cosecant squared x, and don't forget that it is negative. So it's those co's are always negative. They're very unhappy trig functions right there. Excellent. Moving on to the next one. This is the most important one. This is the one that we're going to see, and I don't want it to trip you up at all here. I'm going to rewrite this bad boy. So let's rewrite this. Remember, sine squared just means sine times sine, or it's so much easier if you write it like this. You've got the sine of x, and what are you doing to it? You're squaring it. Because if you write it like this, you can see, oh yeah, that's a chain rule. So it's kind of weird. Yeah, that's the right notation, but it's so much easier for derivatives if you write it like this. Highly, 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 highly recommend it, at least in the beginning while you're getting warmed up on these bad boys. So now it's a chain rule. We're going to say 2 times the bracket. Remember, everything in the bracket stays exactly the same. Drop that outside power 1, so it's 1. And then what's the derivative of the inside now? Derivative of sine is cosine. So these can get pretty crazy. We're going to have chain rules and chain rules and chain rules coming up. So if you can differentiate it there with these brackets, it really helps out. And then if you want to clean it up just a little bit here, we don't need that bracket. It's to the first power. So really this is 2 sine x cosine x. Awesome. Awesome. These can get crazy. All right, here we go. Can we evaluate at a point? Sure. I just kind of want to give you a kind of a tricky looking one here. So again, if I want to evaluate this derivative, first thing I'm going to do is rewrite it. So rewrite this bad boy. So it's 4 times, this is cosine cubed. So we've got cosine of 2x, and we are cubing it. So it's so much better if you can write it like this. Why? So now what's going on here? We're going to take the derivative, and we're going to do our chain rule. So we're going to say 3 times 4 is 12. Still got this cosine of 2x. You rewrite exactly the same what's inside the parentheses, or inside the grouping symbol. Drop the 3 down to a 2. Now, what is the derivative of this inside term? The derivative of cosine 2x is going to be negative sine 2x, because it's the derivative of cosine is negative sine. And don't forget, we have another grouping symbol here. So we have one more grouping symbol. What's the derivative of 2x? We've got this times 2 out here at the end, because the derivative of this is 2. So it's kind of crazy. That's a lot of chain rule in there. That's awesome. Can we clean it up a little bit? Sure, if we want to clean it up to evaluate, but if you want to just plug it in now, I'm going to go ahead and do one more step here. So we're plugging in. Let's go ahead and just clean this up a little bit. So I've got this 12 times this 2 is 24. I'm going to rewrite this. You can leave it in the brackets if you like it. It's actually not bad for evaluating. Cosine 2x squared. That negative I'm just going to put out front here, and I'm going to have the sine of 2x. So let's now evaluate this bad boy here. I'm going to plug in that pi over 6. So normally I don't like to simplify too much. I like to just plug that bad boy in there. But I think in this case it's a little bit easier to see. So I've got what? I've got cosine, and this is kind of weird, of 2 times x, which is pi over 6. And the whole thing is being squared, remember. And then I've got the sine of 2 times this pi over 6. All right, so what is the most important thing is this 2 times pi over 6. Well, they cancel, right? You got boom, boom. So we're really looking at pi over 3. And at pi over 3, if we look at our unit circle, what do we got? I think we got these coordinates right here. So we're looking at 1/2 comma radical 3 over 2. So let's sub those bad boys in. I'm going to say it's negative 24. So the cosine of, excuse me, pi over 3 is 1/2. And it's squared. So this whole thing is 1/2, and then I'm going to square it. The sine of pi over 3 is radical 3 over 2. So I'm going to say it's radical 3 over 2. Boom. And what do we do now? We're going to square that 1/2 and get 1/4. And there's not much I can really do with this radical 3 over 2. It's just kind of stuck like this. And let's finish this out. Let's see, 24 divided by 4 is 6. 6 divided by 2 is 3. So the denominator's gone, so I'm looking at a negative 3 radical 3. That is awesome right there. That is super cool. If that's cool with you, you are good to go. That's pretty much as intense as we'll get with these. A lot of chain rule in there. Awesome. So can we do tangent line? Yeah, let's keep these flowing. We're just going today. So anytime I see tangent line, boom, I'm thinking derivative. So what's the derivative of this? Don't let the pi confuse you. It's just a constant, so he disappears. What is the derivative of tangent? Well, it's going to be 2. Tangent is secant squared x. So there's my derivative. So I want to know what is this will help me find the slope at this point. So let's plug it in. Let's plug in pi. So 2 secant squared of pi. And what is that? What's going on at pi? Well, remember pi is over here. So we're looking at -1, 0. So secant is 1 over cosine. So the 1 over cosine will be 1 over -1. So this will be 2. Remember, it's 1 over -1 squared. So we are squaring this bad boy. So however you want to rewrite that, if you want, some people like to rewrite it as this. This is the same thing, and then they can see, oh yeah, no problems. However you want to come up with that, so you should get, that'll turn into a +1, plain old 2. So the slope of my tangent line is 2. So if I'm going point slope form, I got the slope. That's great. It'll be y minus something equals the slope of x minus, remember the x value is pi. And I just need to know what's the y value. So to get the y value, plug this bad boy in here. Boom. So we're going to find that y value by saying the y is pi plus 2 times the tangent of pi. Well, what is the tangent of pi? Well, remember that's going to be sine over cosine. So that's going to be 0, 0 over -1, 0. So this looks like pi plus 0. So the y value. So it's weird. Pi actually makes pi. Haha, that's awesome. So if you put pi in, you get pi out in this case. So this will be y minus pi equals 2 times x minus pi. So that's my tangent line right there. So that's tangent. Remember, normal lines, you just flip the slope. So if I'm just going to flip that upside down and say the normal line is the same thing, except it's the flip it and change the sign. And there it is right there. So this one is normal, the perpendicular to the tangent. Awesome. We are killing it. Killing it. All right, let's bring the pain here. Let's kind of do everything from the whole chapter. Check this bad boy out here. What is unique about this one? Aha, we have got a product rule going on. We've got a function times a function, so we've got a u times a v. So if you want to write it all out, it's kind of nice. You can say my first function is x squared. The derivative of it is 2x. My second function is just happens to be a trig function this time. And what's the derivative of cosecant? Well, it is going to be negative because it's a cos, so it's negative cosecant 2x and cotangent 2x. Remember, the cos are friends, so cosecant, just repeat it, cosecant, cotangent, the coco. And just be careful, remember, it's also got a little chain rule built in there. You have to say it's times 2 out here at the end because it's the derivative of the inside of the function. So the derivative of cosecant is cosecant cotangent negative. Derivative of the inside is 2. So that's pretty nasty looking. That's okay. Don't freak out. Just follow the rules and we'll be good to go. So the product rule says u prime v plus uv prime. So just plug and chug. Let's plug these bad boys in here. So u prime is 2x. V is cosecant 2x. Plus u was just that x squared. And v prime is that whole terrible looking thing right there. Oh my goodness, it just keeps going and going and going. Can I clean this up a little bit? Yeah, I'm not going to go crazy cleaning this up. The first part is just stuck. It's just 2x times cosecant 2x. That, nothing we can really do with that. Here I've got this negative, so I'm going to make this a subtraction. I'm going to bring this 2 up front, so I've got minus 2x squared. And again, you can't really do much with that. That's just it. So it looks kind of crazy. Don't freak out. We could have some crazy looking answers when we start doing product rule or quotient rule. Same thing with quotient rule. Just plug and chug. Write your parts out. You'll be good to go. Awesome. The last problem. So again, this looks kind of intense, but don't worry. We got this. No worries. Remember, always try to rewrite. So I'm going to rewrite this as 4 minus cosine of x squared. And this is all raised to that 1/2 power. So I've just got myself a chain rule going on here. So let's take this derivative. And I'm going to bring down the 1/2. Rewrite everything in the grouping symbol exactly the same, so it freezes. Boom. There it is. Drop that a power. So it's negative 1/2. Now we have to take the derivative of this inside part. So we froze it. We have to take the derivative of that inside part. So what is the derivative of that? Well, the 4 disappears. What's the derivative of negative cosine? Well, negative cosine turns actually into positive sine. because remember cosine likes to go negative, but it was already negative. And then don't forget, that's great, but don't forget we have another inside right there. We have to take the derivative of the inside of that. So what's the derivative of x squared? Boom, we've got this little 2x here at the end. Let's clean it up just a little bit here because it's all multiplication here. So I can say this 1/2 cancels this 2 out here. This negative is going to move him to the bottom, so I'm going to end up with a fraction. It looks like I've got this square root on the bottom of this 4 minus cosine x squared. And then everything else will be on top. So I've got an x on top. I've got a sine of x squared on top. Is that everybody? Everybody's got a home. There it is right there. So we may get some weird looking answers. Don't freak out. Follow the rules, and you'll be good to go. Good luck on the math check. Peace out.